picture this. You are looking at a breaking dispatch from the World Health Organization, and the date on it is May 4, 2026. So right now, literally as you listen to this, there is a Dutch-flagged luxury cruise ship, and it's just moored off the coast of Cabo Verde. It's got 147 passengers and crew on board. And, this was supposed to be the trip of a lifetime, right? A rugged ecotourism voyage across the South Atlantic. But instead, it has turned into this locked room biological crisis. They've got 7 cases of a really severe, rapidly deteriorating respiratory illness. 3 people are already dead.
Oh, wow.
Right. And 1 more is critically ill, currently fighting for their life in an ICU after being medically evacuated. And the culprit behind all of this is a rare, just exceptionally lethal pathogen known as hantavirus.
Yeah, I mean, it is a highly volatile, completely active medical emergency. And the reason it has the WHO on such high alert is that this specific outbreak is completely defying our standard epidemiological models. Like a luxury cruise ship floating out in the ocean is the absolute last place you would ever expect to find a cluster of this specific virus.
Right, because usually you hear about this with, rural farmers sweeping out their barns, not tourists on a luxury ocean liner. So to understand how this happened, for our deep dive today, we are cross-referencing this live WHO outbreak data with 2 really crucial documents. We have an official CDC briefing on hantavirus transmission and a highly detailed clinical pathology review from StatPearls on a condition called Hantavirus Pulmonary Syndrome.
That StatPearls review is incredibly detailed, yeah.
It really is. And our goal here is to unpack the mechanics of this virus, what it actually does to the human body on a microscopic level, and the precise biological twist that allowed it to board that ship in the first place. But to unravel the anomaly of this Cabo Verde outbreak, I feel like we first need to establish the baseline of what this virus actually is, because it has kind of a wild origin story, right?
It does, yeah. The historical context really sets the stage perfectly here. So hantavirus first emerged into modern medical consciousness back in the early 1950s. This was during the Korean War. You had United States and United Nations soldiers operating in the field, specifically near the Hantan River in South Korea. And suddenly, they just began falling ill with this mysterious hemorrhagic fever.
And they had no idea what it was at the time.
Exactly. I mean, it took decades of subsequent research to finally isolate the virus. And they eventually named it Hantan after that river where the soldiers were stationed. But what we know now, which those field medics obviously didn't, is that hantavirus is not just a single entity. It's actually an entire genus containing over 20 distinct known species.
Over 20. That's wild. And going through the sources, there's this fascinating geographic divide in how those different species affect the human body. It essentially splits the world right in 2.
Precisely. Yeah, the clinical manifestations rely heavily on where you are geographically. So in Europe and Asia, the dominant hantaviruses typically cause an illness known as hemorrhagic fever with renal syndrome, or HFRS. And as the name implies, these strains primarily target the kidneys. The virus damages the renal system, which leads to complications like acute kidney injury, low blood pressure, and internal bleeding.
Right, and the severity of HFRS seems to have this massive range. The data shows the mortality rate varies wildly just depending on which specific strain you happen to encounter in that hemisphere.
It really does. So if a patient is infected with the Hantai or Dobravos strains, the mortality rate sits somewhere between 5 and 15%, which is significant. But then you have another strain called the Sol virus. And interestingly, the Sol virus has spread worldwide.
Oh, wait, really? How did it get everywhere?
Well, its primary host is the common brown rat. So it just hitched rides on ships globally over centuries. But fortunately, the Sol strain is much milder, so it carries a mortality rate of less than 1%.
Okay, less than 1%. But those symptoms, like the kidney failure and the internal bleeding, they do not match the WHO dispatch from our cruise ship at all. Because the passengers off the coast of Cabo Verde, they're dying from acute respiratory distress, not kidney failure.
Exactly. And that points us squarely to the second type of illness, which is localized strictly to the Americas, so both North and South America. Over here, a totally different set of hantaviruses causes Hantavirus Pulmonary Syndrome, or HPS. So instead of attacking the renal system, these strains aggressively target the pulmonary system, the lungs.
Got it.
Yeah. And it was first identified in the United States back in 1993 after this really sudden cluster of unexplained respiratory deaths down in the Southwest. The most common strain responsible for HPS in North America is called the sin nombre virus.
Right, the sin nombre virus. So we have a pulmonary syndrome rather than a renal one. And Looking at the clinical data, the mortality rate attached to HPS is just staggering. It states that up to 40% of people who develop these severe respiratory symptoms do not survive.
Up to 40%.
Yeah. Which is terrifying. But, from an evolutionary standpoint, the virus must have an incredibly efficient way of transmitting itself, right? Because a pathogen that kills nearly half of its human hosts, that isn't going to survive very long if it relies purely on us to spread. We'd die before we could pass it on.
And that is exactly the evolutionary genius of this pathogen. Humans are merely accidental dead-end hosts. The virus actually relies entirely on rodents for its survival and its distribution. So the deer mouse, for example, is the primary reservoir for the sin-number strain in North America. And the real key to this whole dynamic is that the virus does not harm the rodent at all.
Wait, really? The mice don't get sick?
Not even a little bit. The mice are completely asymptomatic carriers. They don't develop respiratory distress. They don't get kidney failure. They simply go about their lives, foraging, breeding. And all the while, they are continuously shedding the virus in their urine, feces, and saliva.
So they are essentially this perfect stealth vehicle. The virus co-evolved with the rodent to ensure its own continuous replication without burning through its host population.
Exactly. A perfectly healthy-looking mouse in a rural cabin or, say, a suburban garage could be actively shedding a lethal biological hazard. And the transmission mechanism to humans is what makes it so insidious. It is almost entirely airborne.
Airborne from the droppings, right?
Right. So when infected rodent excrement dries out over time, the viral particles inside it remain viable. If that environment is physically disturbed, say a farmer is sweeping out a dusty barn or a homeowner is vacuuming out a long closed storage unit, those particles become aerosolized. They just float right up into the ambient air, and the human host simply breathes them deep into the alveolar spaces of their lungs.
Okay, let's unpack this, because the pathophysiology detailed in that Stat Pearls review is incredibly complex. Let's walk through the timeline for a second. So you sweep the garage, you inhale that invisible dust. The clinical review states that the incubation period can range anywhere from 1 to 8 weeks.
Up to 8 weeks, yes.
I mean, that is an enormous window. You could take a trip, clear out a shed, and live your completely normal life for 2 full months before you even feel a tickle in your throat.
It is a massive window. And the prolonged incubation period is really a defining and dangerous characteristic. Because when the illness finally does manifest, it doesn't immediately present as this catastrophic respiratory failure. It actually begins with a prodrome phase that lasts about 4 to 10 days, which basically mimics a severe but generalized viral infection.
So it just feels like the flu at first.
Exactly. The patient develops a fever, a headache, maybe some gastrointestinal issues like nausea. But one of the most prominent hallmark symptoms during this early phase is severe myalgia, so intense muscle aches, specifically localized in the large muscle groups like the thighs, the hips, and the back.
So you feel like you just have a terrible case of the flu. But beneath the surface, the virus is systematically locking on to very specific targets inside you. The source notes it goes after 3 distinct types of cells: epithelial cells, dendritic cells, and endothelial cells.
Right. And that cellular targeting is the actual foundation of that 40% mortality rate. Let's look at what those cells actually do. Epithelial cells, they form the protective barriers on the surfaces of your body, which includes the lining of your respiratory tract. Dendritic cells, they act kind of like the immune system's forward scouts. They process material from the virus and present it to the immune system to initiate a response. But the most critical target here is the endothelial cells.
And those are the ones in the blood vessels, right?
Yes, these are the cells that form the literal lining of your blood vessels.
And the mechanism it uses to infiltrate those blood vessels is fascinating. The virus doesn't just smash its way in, it chemically binds to something called beta-3 integrin receptors on the surface of these cells.
Yeah, and this is where we really uncover the why behind the disease's lethality. Because beta-3 integrins aren't just random handles on the outside of a cell. They are specialized receptors that fundamentally regulate the structural integrity of your capillaries. They control capillary permeability, meaning they dictate how tightly sealed your blood vessels are.
Oh, wow.
Right, so by specifically hijacking the very receptors responsible for keeping your blood vessels sealed, the virus positions itself perfectly to cause structural havoc.
Okay, I need to push back here for a second, though, because the sequence of events seems kind of counterintuitive. The Stat Pearls source explicitly points out that the virus replicating inside the vascular endothelium does not have a direct cytopathic effect.
Right, it doesn't destroy the cells directly.
Right. It isn't acting like a microscopic explosive blowing up the blood vessels. So if the virus itself isn't destroying the cells, what is actually causing the physical damage to the lungs?
What's fascinating here is that the virus essentially weaponizes your own biology against you. The damage is entirely immune-mediated. Remember those dendritic cells we mentioned earlier?
The forward scouts.
Exactly. When they detect this massive viral infiltration happening in your blood vessels, they sound a systemic alarm. Your body detects the intruder and triggers a hyperactive immune overreaction, what we call a cytokine storm.
So the virus isn't blowing up the bridge. It's tricking the body's immune system into calling in a catastrophic airstrike on its own territory.
That is exactly what happens, yes.
Yeah.
The immune system just floods your bloodstream with soluble mediators, specifically pro-inflammatory cytokines like tumor necrosis factor alpha and interferon gamma. Now, under normal circumstances, local inflammation is a perfectly healthy response to fight an infection. It increases blood flow to the area. But in a systemic cytokine storm, the sheer volume of these chemical signals just overloads the system. They cause those beta-3 integrin receptors we discussed to essentially let go. The tight junctions between the endothelial cells separate.
So the capillaries literally start leaking.
Copiously. The structural integrity of the vascular lining fails, and blood plasma leaks out of the capillaries and directly into the alveolar air sacs of the lungs. This creates rapid, severe pulmonary edema. The patient is effectively drowning from the inside in their own blood plasma.
God, that is brutal.
It is. It leads to profound shortness of breath, a massive drop in blood pressure because, the fluid is leaving the vascular system, and ultimately cardiogenic shock. The heart simply cannot pump effectively without the necessary blood volume, and those same inflammatory cytokines actively depress myocardial function. A patient can go from feeling a little breathless to requiring mechanical intubation in a matter of hours.
Which brings us right back to the May 2026 WHO report and the locked room mystery of our luxury cruise ship. Because now that you, the listener, understand the precise mechanism that this virus requires aerosolized rodent droppings to infect a human, and that humans are dead-end hosts, we have a glaring contradiction on our hands. How does a maritime vessel carrying 147 people end up with 7 severe cases of Hantavirus Pulmonary Syndrome?
Right, to figure that out, we really have to trace the epidemiological timeline of the voyage. So the ship departed from Ushuaia, Argentina, on April 1st. From there, it pursued a true ecotourism itinerary, making stops in really isolated, rugged environments. Mainland Antarctica, South Georgia, and Tristan da Cunha. Now, the index case, Case 1, an adult male, he started showing symptoms on April 6th while the ship was at sea. He deteriorated rapidly and died by April 11th.
Which perfectly aligns with the rapid pulmonary edema and cardiovascular collapse we just discussed.
It does. But then the situation escalated. Case 2, an adult female, began exhibiting symptoms shortly after. She was medically evacuated to a hospital in St. Helena and later died during a transfer flight to Johannesburg on April 26th. But what is absolutely critical here is that Case 2 was a registered close contact of Case 1. They actually shared accommodations. And then we have Case 3, evacuated from Ascension Island, who is currently fighting for his life in intensive care.
Okay, but let's apply some critical thinking to this timeline. The WHO report notes that both Case 1 and Case 2 had traveled extensively in rural Argentina before they ever even boarded the ship in Ushuaia. Given the clinical fact that the incubation period can be up to 8 full weeks, couldn't this just be a massive coincidence?
How do you mean?
Well, isn't it highly probable that these two people simply swept out a dusty cabin or hiked through the same contaminated barn in Patagonia a month prior, inhaled the same aerosolized mouse droppings, and the long incubation period just happened to run out while they were sharing a cabin at sea? Like, why is the WHO treating this as a human-to-human transmission event?
It's an excellent question, and honestly, it is exactly the hypothesis epidemiologists would test first. However, the geographic origin of the ship points to a much more alarming biological reality. We established earlier that the Sin nombre strain in North America is strictly transmitted from rodent to human, but this ship departed from Ushuaia. And the predominant hantavirus strain in South America, specifically circulating through the rodent populations of Argentina and Chile, is the Andes virus.
And the clinical review highlights a very specific, terrifying characteristic unique to the Andes virus.
It does. The Andes virus is the single known exception in the entire hantavirus genus. It is the only strain structurally capable of human-to-human transmission.
Right, the only one.
The only one. While the exact virological mechanism that allows the Andes strain to spread between humans, while, its genetic cousins cannot, is still heavily researched, the epidemiological data is absolute. It usually requires prolonged, intimate contact, such as sharing a small, poorly ventilated space, like a cruise ship cabin.
Oh, wow. So the timeline combined with the specific regional strain dictates the WHO's response. They aren't looking for mice in the ship's galley. They are looking in the passengers.
Precisely. This is why the WHO Outbreak Dispatch didn't focus on deploying exterminators to the ship. Instead, they issued urgent directives for the crew and passengers to maximize physical distancing and to immediately isolate anyone presenting with even mild flu-like symptoms. The true danger of the Andes virus is that a single passenger who inhaled dust in an Argentine forest can bring the pathogen onto an isolated vessel and directly infect their family members.
So what does the medical intervention look like for those passengers or for anyone who develops Hantavirus Pulmonary Syndrome? I mean, you have an up to 40% mortality rate, a hyperactive immune system destroying the lungs, and no way to reverse the vascular leak.
Well, the most sobering detail in the StatProl's review is the absolute lack of targeted therapeutics. There is no cure, there is no approved specific antiviral drug that can neutralize a hantavirus. Broad-spectrum antibiotics are completely useless because we are dealing with a viral agent, not a bacterial infection. And even broad antiviral medications like ribavirin, which are heavily utilized in treating other severe diseases, have been tested extensively and proven entirely ineffective against HPS.
So the entire medical strategy basically shifts from curing the disease to simply keeping the human body alive long enough for the immune system to realize its mistake and stand down.
That is the essence of supportive care, yeah. These patients require immediate admission to a highly equipped intensive care unit, but treating them requires navigating one of the most perilous medical paradoxes in critical care. It revolves entirely around fluid management.
Right, because the central crisis is that the blood plasma is leaking out of the capillaries and filling the lungs. So how do you manage a patient whose vascular system is compromised like that?
It's incredibly difficult. When the endothelial cells separate and the plasma leaks, the patient's blood pressure just plummets. They enter hypovolemic shock. So to keep the heart pumping and ensure oxygenated blood reaches the brain and vital organs, doctors must aggressively administer intravenous fluids. They have to maintain what clinical guidelines call normal high fluid filling pressures.
Okay, let me make sure I'm visualizing this correctly. It's like trying to maintain water pressure in a house where all the pipes have sudden microfractures. Right. You have to turn up the main valve and pump more water into the system just to keep the water flowing to the faucets. But because the pipes are fractured, pumping more water into the system just means you are flooding the drywall that much faster.
That is a brutally accurate analogy. If the medical team does not administer enough IV fluid, the patient's cardiovascular system collapses and they die of shock. But if they administer too much fluid, they accelerate the leakage into the lungs, worsening the pulmonary edema, and the patient effectively suffocates. The doctors have to walk a microscopic tightrope, continuously monitoring the patient's hemodynamic status hour by hour.
That sounds impossibly stressful.
It is. But the data shows just how crucial this balancing act is. Because if that fluid management is executed perfectly, avoiding excess volume while maintaining blood pressure, almost 50% of HPS patients can actually survive without ever needing mechanical intubation.
That is a staggering testament to the precision of modern critical care. But the clinical review did mention one experimental intervention that goes beyond just fluid management, something that actually addresses the viral load, relying on people who have already survived the infection.
Yes, the use of convalescent plasma. This involves taking fresh, frozen blood plasma from patients who have successfully fought off HBS and recovered. Their plasma is saturated with neutralizing antibodies, specifically tailored to the virus. When transfused into a critically ill patient, it provides immediate passive immunity. The StatProl's review cited a study where administering convalescent plasma dropped the mortality rate dramatically, from 32% down to just 14%.
Which is an incredible breakthrough, but acquiring fresh, specifically typed convalescent plasma in the middle of the South Atlantic Ocean on a quarantine cruise ship is an agonizing logistical hurdle. Now, all of this sounds like a deeply exotic nightmare, right? A rare South American strain, a luxury ship, a 40% mortality rate. But the reality check from the CDC briefing is that you do not need to go on a rugged ecotourism trip to Patagonia to encounter this genus of virus. 50% of all hantavirus infections occur right at home.
And that is a vital reality to internalize. The preventative measures are universal, whether you are managing a rural estate or opening up a suburban storage unit. The fundamental goal is always preventing the aerosolization of rodent excrement. The CDC emphasizes sealing structural holes to prevent rodent entry and, of course, securing food sources.
But I think the most actionable piece of intelligence for you, the listener, is how to actually clean a compromised space. Say you walk into a garage that has been locked up all winter, and you see mouse droppings on the concrete. The immediate, instinctual human response is to grab a broom and sweep it out, or pull out the shop vacuum.
And biologically speaking, dry sweeping or vacuuming is the absolute most dangerous action you can take.
Wait, really? The most dangerous?
Yes, because the mechanical force of the broom bristles or the exhaust of the vacuum cleaner instantly launches the dormant viral particles into the air, creating the exact aerosolized cloud the virus needs to reach your lungs. The official protocol is incredibly strict here. You must exclusively use wet cleaning methods.
So you saturate the area first.
Heavily. You spray the droppings and the surrounding area with a commercial disinfectant or a 10% bleach solution. You let it soak for at least 5 minutes to neutralize the pathogen, and then you wipe it up with a wet paper towel. The moisture physically traps the particles, making it impossible for them to float into the air. Furthermore, the CDC recommends heavy ventilation.
Like opening the garage door.
Right. Open all doors and windows for at least 30 minutes before you even begin cleaning. Let the fresh air circulate, and crucially, let the sunlight in. Ultraviolet light from the sun degrades the lipid envelope of the virus, actively destroying it.
Wow. It is a profound realization that simply choosing a wet paper towel over a dry broom can literally be the difference between a clean garage and a fatal cytokine storm. So, just to synthesize this deep dive, we started by tracing the history of a mysterious hemorrhagic fever in the 1950s, uncovering a globally distributed family of viruses that have perfectly co-evolved to use rodents as asymptomatic stealth carriers. We broke down the exact cellular mechanics of how the virus hijacks our beta-3 integrin receptors, triggering a self-destructive immune cascade that fills the lungs with fluid. We saw the agonizing, paradoxical tightrope of medical fluid management. And finally, we decoded the May 2026 Cabo Verde anomaly, revealing how the South American Andes strain, with its unique capability for human-to-human transmission, turned a luxury ecotourism voyage into a deadly biological locked-room mystery.
If we connect all these clinical and epidemiological facts, it raises a lingering, highly provocative thought about how we interact with the natural world.
How so?
Well, the clinical data clearly states that exposure frequently occurs during ecotourism or forestry activities, and that the virus can lie dormant in the human body for up to 8 weeks. Now, consider what that timeline actually means in our globally connected, highly mobile era. You could travel to a remote, entirely untouched sylvatic ecosystem in South America. You could hike through a forest where pathogens like the Andes virus have circulated quietly between rodents for millennia.
Right.
And then you simply get on a plane. You fly back to a high-rise apartment in a major, heavily populated metropolis, thousands of miles away from that wilderness. You go to the office, you share meals with your family, you live your completely insulated modern life for 2 full months before a wild, lethal pathogen suddenly activates in your vascular system. It completely blurs the line we mentally draw between the untamed wilderness and our modern safe havens, forcing us to question the invisible, highly consequential biological souvenirs we might be bringing back from our adventures long after the trip is over.